Welcome back to one of the last lessons, 5.4, the fundamental theorem of calculus. Now this is one of the most important lessons in integration. This brings everything together. This shows you what a true integration is. Now what we're going to do today, evaluate a definite integral using the fundamental theorem of calculus, the main gist of the lesson. Understand what the mean value theorem is for integrals. You already know what it is for derivatives. Find the average value of a function over a closed interval. Understand the second fundamental theorem of calculus, and to understand the net change theorem and how it's used. That's a little teeny thing at the end. Most important though is the definite integration from upper limit to a lower limit. Now, to start off, let's just explain what the fundamental theorem of calculus pretty much is. Now, when you have a curve, this brownish curve right here, right between your 2 points, what you have is two types of lines that are associated to that curve involving calculus. Now this first line, the one that connects 2 points, is called the, do you remember? It's called your change in y over change in x, right? That's how you get your slope. And what's that light blue line called? Do you remember? It's called the secant line. Remember, a secant line intersects 2 points. Now this one's a little different. This, I guess you could say like lime greenish line. Has pretty much the same slope. The difference is this is your tangent line because it only hits the curve at 1 point. All right. Sorry. Whew, sneeze. All right. So that's about change in y and change in x. It's not exactly because you don't have these 2 points connected, so it's a little bit different. But what you do is you're still changing your y and you're changing your x. So it's like a different y and x. All right. So area, all right, and the tangent line changes between 2 points depending on where you're on the curve, remember, and the secant line always stays the same. Now, as far as area goes, area is more of integration. Remember, slope is kind of derivatives, area is like integration, area under a curve. So if we were just to estimate this, area right here, remember how we would find it? Oh, sorry, this is differentiation. I jumped ahead. Change in y over change in x, right? No, you wouldn't divide in order to find the area. Find the area of rectangles. Remember we did that with circumscribed and inscribed, the maximum area, minimum area, all that fun stuff, the summations. You would multiply the two, length times width, okay? Now, if I wanted to find the area of just the area under the curve, this would be the area of the whole rectangle. This would be about the area of the rectangle. In this case, it'd be a little bit less, but it'd be the area under a curve. That's why it's about multiplying. And this right here is your integration. Now, what you guys need to know real quick, though, is what do you notice about the two formulas for slope and area? Differentiation and definite integration have a, what type of relationship do you think that is? If you said inverse, you are correct, because one's multiplication, one's division. Okay, so we're going to be working more with the... Got it? So let's put everything together. Let me get that over here. There we go. So, theorem 5.9, fundamental theorem of calculus. If f is a function, and it's continuous on the closed interval, meaning no holes, okay, no asymptotes, ab, then f is an antiderivative integral of f on the interval ab, then the following is true. So now you're saying, what is f of x from a to b? This is the start x. This is like your x1, your x2. All right, so it would be actually your derivative with b plugged in for x minus your derivative with b plugged in for a. All right, so because we know the integral of f of x is f of x plus c, but we no longer have to worry about c's because we're finding an actual numerical value now. All right, so here's an example of how to do this, and it's quite easy. Once again, this is the most important part of the lesson. Now, first thing you would do, just like you did before, is step 1. What do you think it is? If you said to integrate, you are correct. So I'm going to integrate 6x plus 1. So don't worry about the upper and lower limits or terms yet. So if you did that, you got 6 times x squared over 2 plus x to the first over 1. All right, which is 6 divided by 2 is 3, x squared plus x plus c. So far, it's easy, right? Step 1. You've done that. find f of b. So this is like pretty much from 5.1. So the way to find f of b right here is you have to know which one your a and your b is. Once again, a is your lower limit, b is your upper limit. So b is 4, a is 1. You're just going to take b, which is 4, and plug it in for x. So f of 4 is 3 times x, which is 4 squared plus 4 plus c. 4 squared is 16 times 3 plus 4 is 52 plus c. All right, we still have the c right now. I'll tell you what to do with that in a second. All right, ready for the next one? Oh, it's TV. Bothering me. All right. What do you think you'd find f of b? You find f of a. All right, how do you find f of a? You're going to take a, which is 1, and you're going to plug it in for the x's. Now, you're plugging it into the integrated form, not the original. The problem that you integrate. So 3 times 1 squared plus 1 plus c. 3 plus 1 is 4 plus c. This is your f of 4. This is your f of 1. Now, your last step here is going to be very simple. It is going to be to subtract the 2. So you take 52 plus c, and you subtract 4 minus c. What is 52 minus 4? 48. What is c minus c? 0. So technically, you don't even need these c's. Okay? When you're doing a definite integration. Okay? When you're actually plugging in numbers. Because the c's cancel out. All good? Awesome. Ready for the next problem? Now, here's the guidelines for using this theorem. So I created this real quick, make sure it's easier to use. Number 1, step 1. You want to provide that you can find the antiderivative. So you have to be able to find the antiderivative. It can't be a no solution. All right, you have to find a way to evaluate the definite integral without using the limits of a sum. So you're going to try to do this without using summations, okay? Which is like 5.2, 5.3, like the Riemann sum and things like that. So when applying the fundamental theorem of calculus, the following notion is very convenient, meaning this is something that would be good to use. F of x dx from a to b equals the integral, capital F of x just means your integral of this from a to b. Now this is a little bracket here, so you just use 1. It's not a closed bracket. Now this bracket right here means you integrated this already. So that means this is integrated, this is my lower limit, this is my upper limit. So when you do that, what you have is your f of b minus your f of a. Okay, so anytime you see this bracket, it means it's integrated. So let's try an example right here. What I want you guys to do is integrate this and write it in this form. All right, so as you know, the power integration rule, you add 1 to the exponent and then you divide by that number as well. So x to the 4th plus over 4. And then remember, we don't need the c's here because we are finding actual answers. You're going to integrate from 1 to 3. And this just means x equals 1 is where you start, x equals 3 is where you end. So you're just doing the graph in between those two numbers once again. All right, so what you do next is f of b, take your 3, plug it in, so it's 3 to the 4th. Where are we at? 3 to the 4th. Oops, sorry. F of b minus f of a, that's what you got going on right here. So your f of b is 3 to the 4th over 4 minus f of a, which is 1 to the 4th over 4. All right, you're just plugging both numbers into that, subtracting the 2. 81 over 4 minus 1/4. Since they have similar denominators, you just subtract the numerators. 81 minus 1 is 80 divided by 4. 20. That's it. See? Here's why you don't use the constant. Because I remember I hammered in 5.1, you have to do plus c, you have to do plus c, you have to do plus c, because you don't know what the constant is unless we're actually finding it. Now, the reason you don't do the constant is, when you do the constant, say I said, okay, this is f of x plus c. I need to put my plus c in. When I type in b and a, all right, into this is f of b plus the constant, because you don't plug a b into the constant because it has no variable, all right? And then you subtract f of a, whatever that is, and it's the same constant because I'm not plugging the a value in there, all right? So these are always going to be the same. And when you subtract two numbers that are the same, you get, they become 0, all right? If you want, if it makes you happy, you can put the plus c's on every time and just erase them in the end. But once again, you don't have to because you're finding an actual number. All right? That makes sense? Because these are always going to be the same, because you can't plug actual values in for them. That's why they disappear. C minus C is 0. Got it? Let's do a bunch of examples now. Going over this. So first one, evaluating a definite in a row. So we'll work through the row number 2 together, then you guys are going to do tons on your own. Step 1 is what? Integrate. So you got x cubed over 3 minus 3x from 1 to 2. Notice the bracket now. All right, so we got to find f of b first, right? So f of 2 is 2 cubed over 3 minus 3 times 2. All right, now it's just calculator work. 2 times 2 times 2 is 8 over 3 minus 6. And then you subtract it, you get negative 3 to the third, negative 3.333, okay? If you use a fraction, just use a decimal, doesn't really matter. Fractions are actually much more accurate though, so probably better. If you make this negative 10 over 3, 100% good as well. All right, because this is 8 over 3 minus, have to multiply that by 3 over 3, 8 over 3 minus 18 over 3, all right? Next one, f of 1, so you got 1/3 minus 3, 1/3 minus 9 over 3, so that's negative 2 2/3, or negative 8/3. Take these two numbers, f of b minus f of a, so you subtract them, so this becomes negative 3 1/3 minus a negative, which is plus 2 2/3. All right, negative 10/3 plus 8/3, so you get negative 2/3 as an answer. You want to use a calculator, you want to use your brain, whatever you want, as long as you get the right answer. So why don't you guys try 3 and 4? Now for problem 3, you just have to rewrite the problem first. All right, see what you did? Rewritten form is 3x to the 1/2. Remember, anytime you have the square root, it's just x to the 1 over whatever this is. If there's nothing there, it's a 2. All right, so when we derive this, 1/2 plus 1 is 3/2. So 3 to the 3/2 over 2/3. Remember, when you divide by a fraction, you multiply by its inverse, so you just do 2/3. 2/3 times 3 is 6 over 3 is 2. All right, x to the 3/2 from 1 to 4. All right, or you can do 3 divided by 3 is 1, and then the 2 jumps to the top. Cut myself. Now, we have our integration. We're going to plug in 4, we're going to plug in 1. So, 2 times 4 to the 3/2, so this is pretty much 2 times 4 to the third. And whatever that answer is, 64, you take the square root. So that becomes 8. 2 times 8 is 16. 2 times 1 to the 2/3, so that's 2 times 1, which is 2. Subtract the two numbers, 16 minus 2, and you got 14. Not too terrible, right? All right, for number 4, you're going to have to go to your formula sheet, and you know the integral of secant squared should be tan x, right? So it's just tan x from 1 to pi over 4. Now, tan pi over 4 equals 1. Tan 1 equals 1.56. Now, if you got the wrong answer, it was because you didn't put your calculator in radians. So make sure your calculator goes in radians before you type that stuff in. 1 minus 1.56 is negative 0.56. Once again, you have to use radians with trigonometric problems. All right, so change the mode from degrees to radians, or you can use a unit circle if you like, or you can use a trigonometric chart. All right, all those things work to get the answers, but you got to make sure you have them in the right form. Got it? Awesome. Let's go to 5. Why don't you try 5 and 6? All right, integral of 5. 6x squared over 2. 6 divided by 2 is 3x squared. So now what I'm going to do is I'm going to plug some stuff in. So 3 times 2 squared is 3 times 4 is 12. Hey, that's pretty easy. A 0, even easier. 3 times 0 is 0. 12 minus 0 is 12. So the answer is 12. So what that means is the area under that curve, 6x, which is like a linear curve from 0 to 2, is 12 units. All right, let's see. Integral of 5 is 5x, so 5 times 9 is 45. 5 times 4 is 20. 45 minus 20 is 25. All right. Integral to that curve from 4 to 9 is 25. All right. Let's go do some more. 7, 8. Ready? All right. 2. 1 plus 1 is 2. 2x squared over 2 minus x. 2 divided by 2 is 1, so it's x squared minus x from negative 1 to 0. Negative 0 squared minus 0 is, that's a tough one, 0. Negative 1 squared is 1. 1 plus 1 is 2. 0 minus 2 is negative 2. See? Told you it wouldn't be too bad. Notice, variable changed. But as long as you're matching this variable, you're okay. So whatever letter this is, has to be whatever variable integrating. If this wasn't a v right here, and this was, say, an x, these would both be just derived to the x power, so you just add an x onto both. We'll get to that later. Anyway, derivative, derive it just as normal x, doesn't matter what letter you use. V squared over 2 plus 4v, negative 3 halves, v squared plus 4v from 2 to 5. So you type in your v first, which is 5. Negative 3 halves, 5 squared plus 4 times 5. 25 times 3 is negative 75 over 2. Plus 20 or plus 40 over 2. 75, negative 75 plus 40 is negative 35 over 2. Or negative, what is that? 17.5, negative 17 and a half. All right, all are okay answers. Type your 2 in, you get, this is an easy one, 2. Negative 35 over 2 minus 2 is negative 39 over 2. All right, once again, negative 19.5, negative 19 and a half. All right. All right, do 2 more problems. See, you're getting a lot of practice in here. And now we're going quick. All right, t cubed over 3 minus t squared from negative 1 to 1. Plug the 1 in. 1 over 3 minus 2. 1 over 3 minus 6 over 3 is a negative 5/3. Type in a negative 1. So this becomes a negative 1/3 plus 2. So negative 1/3 plus 6 over 3, which is a positive 5/3. Now, the answer is not going to be 0 because you're not adding them. It's negative 5/3 minus 5/3, which is negative 10 over 3, which is, which is negative 3 1/3, negative 3.3 repeating. Got it? All right, let's look at problem 10. Derive, it's a 3, 2, and an x. So x to the third over 3, x squared over 2 minus 3x. 6 divided by 3 is 2x cubed. 2 divided by 2 is x squared minus 3x from 1 to 7. Plug in your stuff. You plug in a 7, you get 714. Plug in a 1, you get 0. 714 minus 0 is 714. See? Ready for number 11, 12? 11 and 12. It's all you. Oh, getting some exercise here. Now, you see that? What do you have to do before you integrate it? Expand it. FOIL. All right? So technically what you have to do is 2t minus 1 times 2t minus 1, and then you integrate it. This becomes 4t squared minus 2t minus 2t, which is your minus 4t, plus 1. And now you integrate it. That's why this was lower. All right, so 3, 2, t, and notice dt and t. So you got 4 times t cubed over 3 minus 4 times t squared over 2 plus t from 0 to 1. 4/3, negative 4 halves is negative 2 plus t. All right. Still good? Plug in your 1. This becomes 4/3 minus 2 plus 1, which is 1/3. Plug in 0. 0 minus 0 plus 0. It's a tough one. 0. And your answer is 1/3 minus 0, which is 1/3. All right, so sometimes you do have extra steps. You can't integrate this, then FOIL it. You have to FOIL it first, just the way things work. And there is no chain rule for integration. There's something called a substitution rule. It was later, but no chain. Problem number 12. Integrate. So you got x to the 4th over 4 minus 9x squared over 2 from -1 to 1. This becomes 9/2 or -4.5. All right, you don't have to pull the 1/4 out. I just think it's easier to do in the end. Take 1, put a 1 in. You get 1/4 minus 9/2, or 1/4 minus 18 over 4, which is -17 over 4. Put your -1 in. You get the same answer, because anytime you raise a negative number to an even power, it equals a positive number. So your answer is also -17 over 4. Now, because these are the same, -17 over 4 minus a negative, that's a plus, your answer is 0. So you may say, how can I have an area of 0? And I discussed this with you before. The reason for is this is a symmetric, I think it's like odd symmetry graph right here, and you're going from -1 to 1. So what that means is you have enough negative area, the area under the curve, equals the area above the curve. So you do have two areas. You have the area from -1 to 0, which is a certain number, but it's negative, and the area from 0 to 1, which is a certain number, but it's positive. Those numbers are equal, and a negative number times a positive number that are the same equals 0. So the total area is 0. Okay? And that's going to be important later on when we do things that you want to add up both areas together. But for now, we just find the total area. So, do the next two. Once again, you're going to rewrite problem 13. All right? 3x to the -2 plus 1. -2 plus 1 is -1. So it's 3 to the x to the -1 over -1 minus x. All right? That's pretty easy. You can put the x on bottom if you want. You can leave an x to the -1 on top if you want. It's all preference. I like to put it here, though, because it's easier for me to do this in my head. So, -3 over 2 minus 2, or -3 over 2 minus 6 over 2 is you -7 over 2. Wait. Sorry, minus 4 over 2. Math a little slow today. Put 1 in here, -3 over 1. So -3 minus 1 is -4. -8 over 2, if you want to put it that way. Subtract the 2 and you get a half. All right. This one, rewrite it, integrate it. Use, match for good. All right, good to go. U minus u to the -1/2. Same thing we did over here, pretty much is backwards. So it's u squared over 2 minus, and a minus is a plus. U to the -1 or 1 over u. (1/2) -1 squared, so 1/2 minus 1 is a 1/2. 1/2 times 4 is 2, minus a half is 3/2. 1/2 minus 3/2. 2/2. -2/2, which is -1. All right. Pretty good? You feeling it? Good. 2 more. Then we'll get to some tough ones. This is a little tougher. Rewrite this first. That's your hint. T squared, t minus 2 over t to the 1/2. Do we know a quotient rule? We don't. So you have to rewrite it one more time. What can we do next? I'll give you a hint. Is that a good hint? No. You split it up. You can divide both of these by t to the 1/2. So t divided by t to the 1/2, 1 minus 1/2 is t to the 1/2. -2 divided by t to the 1/2 is -2 t to the -1/2. So you just divided both these numbers by the denominator, as we did many times this year. So now you're left with t to the 1/2 minus t, 2t to the -1/2. This, and this are all equal, just written different ways. But we can't integrate this or this, but we can integrate that. That's why we did this. So 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. So 3/2 over 3/2. 1/2 over 1/2. Now, when you divide, remember you multiply by the reciprocal. So this becomes a 2/3. This becomes -2 times 2, which is -4. All right. So 2 times 2 is 4. You flip that and you get there. That. There. That's not a word. Word there is a word, but it's not used properly. Now, you take the 4, plug it in here. 2/3 times 4 to the 3/2. So this is 4 to the 3rd, which is 64. The square root of 64 is 8. 4 to the 1/2 power is the square root of 4, which is 2. And you end up with -2 and 2/3, -8/3. F of A, when you plug 1 in here, this is obviously 1 and 1/3. So 2/3 minus 4, 2/3 minus 12 over 3, which is -10 over 3 or -3.5. Subtract the 2, that means this becomes a plus. -8/3 plus 10/3. Always nicer to put it in here than there. Yeah, it's just 2/3. You don't have to, but it is what it is. We all right? All right, 16. As I get to my next seat, you guys should be finished with drawing. All right. 1/3 plus 1 is 4/3. Reciprocate 3/4 speed to the 4/3 from -3 to 3. Plug a 3 in there. 3 to the 4th power is 3 times 3 times 3 times 3. 81 cubed root of 1 is some decimal. 3.25. Same thing here. Negative number to a even power becomes positive. So your answer is actually going to be the same. You have the same thing minus the same thing. And your answer is 0. Once again, symmetrical. You're going from the same distance each way. Be good, please be good. Oh, rewrite and solve these. All right. 1/3 minus 2. 1/3 plus 1 is 4/3. So x to the 4/3 over 4/3 minus 2x. Reciprocal 3/4 x to the 4/3 minus 2x. You're going to plug your 1 in there and you get -5/4 as an answer. You're going to plug a -1 in there. When you do that, you get 11 over 4 as an answer. Subtract the 2. -5 minus 11 is -16 over 4. Oh, that looks familiar. -4. 18. Rewrite x on bottom by itself means 2x to the -1. But you can't integrate x to -1 because -1 plus 1 is 0. So we actually have to use our special integration formula. Do you guys remember that? Hopefully you did. Anytime you have an x is in the denominator, you have to use the line. All right. So 1 over x dx equals ln absolute value of x plus c. So the answer to this would be 2 ln absolute value of x from 1 to 8. Now in your calculator, 2 ln by the natural log 8 equals 4.16. Sorry, I call it ln, which is unmathematical. 2 natural log 1 is 0. 4.16 minus 0 is 4.16. See, actually quite simple to do as long as you use your right formula. Got it? That was a trick one. To throw you for a loop. Rewrite, solves. This actually has a rewrite and a division. This has a rewrite and a distribute, and you solve and you solve. So go. Ready? X divided by 3 is 1/3 x. This becomes minus x to the 1/2 over 3. So it's -1/3 x to the 1/2. I did it all in one step. Need to save space here. So x squared, x to the 3/2. So x squared over 2, x to the 3/2 over 3/2. 1/3 times x over 2 is 1 over 6. This should reciprocate. So the 2 goes to the top, becomes 2. 3 times 3 is 9. 2 9s. Type the 1 in. 1/6 minus 2 9s is -1 over 18 because this becomes 3 over 18 minus 4 over 18. That's where you get the 1 over 18 from. And then when I type a 0 in, your answer becomes 0. Answer is negative 1 over 18. This one, you're going to distribute that little guy in there. So you get 2t to the 1/2. 1/2 plus 1 is 3/2. So add 1, 3/2 and 5/2. Reciprocate. 2 times 2 is 4/3. 2/5. When you type 2 in here, 2 to the 2/3 is square root of 8. 2 to the 5/2 is 8, 16, 32, square root of 32. 4/3 times that is 1.51. Really no easy way to do it. Oh, but the 0 and the 0 is a 0. 1.51 minus 0 is 1.51. A lot of times 0 do give you 0 as an answer, but not always. Right? Be all good? All right. Let's finish up with some tough ones. 21. All right. Integrate. 4/3 over 4/3. 5/3 over 5/3, right? 3/4, 3/5. Type in 0, you get 0. Type in -1. -1 to the 4th is a positive 1. -1 to the 5 is a negative, so this is positive, and 2 negatives here is a positive. 3/4 over 3/5, need the common denominator, which is 20. So 15 over 20 plus 12 over 20 is 27 over 20. 0 minus that is negative 27 over 20. I could have done that on one slide. I just expanded to give you guys a little bit more. All right, ready for the next one? That looked a lot worse than it did, didn't it? All right. This one's a little tricky. All right, so you got it? First step. 2x to the 1/3. Right here, 2x to the 1/3. You're going to divide both of these by 2x to the 1/3. 1 minus 1/3 is 2/3. 2 minus 1/3 is 5/3. Okay, you're just using your exponential rule. X to the a over x to the b equals x to the a minus b. 5/3, 8/3. 1/2 times 3 over 5 is 3 over 10. 1/2 times 3 over 8 is 3 over 16. Oh, look at that. I didn't even have to do it in my head. All right, so you reciprocate, you multiply denominators, multiply numerators. 3/10 and -3 over 16. Type in your b, type in your a. -1 in here, this just becomes -1. Because this is even, this becomes a positive 1. -3/10 minus 3 over 16. Common denominator here is 80. So this would be -24 over 80 minus 15 over 80, -39 over 80. Type it in -8. You get -96 over 10 minus 48. All right. So -96 over 10 minus 480 over 10 gives you -288 over 5. All right. That equals about, oh, that's a big number. 50 plus 30, 56, 57.6. Oh, I forget. All right. So you subtract the 2, use a calculator, you get 57 and 9/80ths. Or that over 80, or 57.11. All right, not too terrible, is it? You probably got this because you probably turned those into decimals. But which answer is right? They're all right. This is the best answer right here. This is also really good because it's the same. This one's like an estimate, so it's not the best, but it's good enough. All right? 2 more problems. Now we're going to do some trig. And then we're going to get into the second half of the lesson. This is the first half. The second half is a little easier. No, it's not. All right, so first thing you do is you integrate. Integral 1 is x. Integral of sine x is negative cosine x. You plug your pi in first. All right, so this is just x minus cosine x. I don't like pluses and minuses together. pi minus cosine pi is pi minus -1, which is pi plus 1, which is 4.14. Because pi is about 3.14. I round to the 100th place just because I like to. Okay? Want to round a little higher, it's fine. You don't really want to go to the 10th because you want to be a little more accurate. F of A is 0. 0 minus cos 0. 0 minus 1 is a -1. What you're going to do is -4.1 minus 1 is 5.14. Or it could also be pi plus 2. What do you have to make sure? You have to make sure calculators in radian. All right? You can also use graphs and all this stuff. Next one. 2x plus sine x. 2 times pi plus sine pi is 2 pi plus 0 is 2 pi. You can call it 6.28 if you want. I like to leave it as 2 pi, 0, 0, and you get a 0. 2 pi minus 0 is 2 pi, or, oh, I didn't even put it, 6.18. All right, whatever you choose, because it just stays in the pi form. It's easier for me. You okay? 526. Now we're going to jack it up a level. This is a little more advanced than what we've been doing, but hey, always good to do extras. What do you think you have to do here? You don't have a quotient rule. If you said rewrite it, you are correct. So if you didn't say rewrite it now. Giving you every chance to get this right. So you would divide both of these things by cosine squared. So 1 divided by cosine squared, negative sine squared divided by cosine squared. Now what you know is sine squared plus cosine squared equals 1. Oh, I was going to do the wrong way. Did you guys remember that? It's called a trig identity. That's from last year. So this is 1 minus sine squared. So what does that equal? It equals cosine squared. How do you know to use that? You don't. In college, what you're going to have to do is figure out when and how to use all these trig formulas with no teacher helping, okay? Especially in physics. Extremely annoying, extremely time consuming. But once you figure out what trig identity to use to reduce everything, you're good. So we know this top piece equals cosine squared. This, what's anything divided by itself? 1. So your answer just becomes the integral from 0 to pi over 4, 1 d theta. Now if I did 1 over cosine squared and sine squared over cosine squared, I would get, what would I get? Secant squared minus tan squared. But that wouldn't have helped us. I guess we could have integrated both things individually, but we don't know the integral for tan squared. So that's not good. That's why we had to use this method. Now, integral of 1 is x. So pi over 4 minus 0 is pi over 4. And there's your answer. See how easy that was? Here's your hint here. All right, I'm going to give you a hint. This is what you're going to have to change. You know tan squared minus plus 1? What formula to use? Well, if you use the formula 1 plus tan squared theta equals secant squared theta, you are correct. So secant squared over secant squared is 1. 0 to pi over 4 gives you integral of x. And the answer, once again, is pi over 4. Just a coincidence they both have pi over 4. I could have put any number here, and that's what your answer would have been. All right? No, you're not going to get anything that's difficult on tests. But you do need to know, this is upper level, figuring out what trig formula to plug in there to switch things around to get something that you can indeed integrate. All right? You okay? Now you're mad. All right. This ends the easy stuff. Where we at? That's the ends easy. Now we're going to up it a level. This is for you guys that really like math and really like to go above and beyond. So you have to really pay attention here because the concept is quite difficult. But it's actually easy if you understand it. So this is very difficult to set up these slides too to figure out. This took years to figure out the best way to explain this. You have the original equation right here. You're graphing 3, absolute value of x minus 6 dx from 0 to 7. Now what you know about absolute value is what? It makes everything inside the absolute value symbols positive, right? So that means your graph never goes down. It always stays up, all right? Unless this number right here is negative, then it would always go down. But this piece inside is always positive, no matter if it's negative or positive. and it forms the v. Remember, absolute value goes like this. So first thing you're going to do is you're going to rewrite it as a piecewise function. You have to rewrite it as a piecewise function because you have to create two functions that are both going to be positive from one negative function. So how do you think you split this up? We're going from 0 to 7, so we're going to go from 0 to something, and then from something to 7. So what number do you think you split it at? I'll give you a hint. The x minus 6 right here is going to help us out. Does anyone have an idea yet? So the way to find this is you set the inside of the absolute value brackets equal to 0 when you solve for x. And that's going to be the number that you stop at, okay? So watch how this works. X minus 6, the number inside. X equals what? 6. So that means I create two functions here. Now when you create these functions, I am going to say your answer, if the answer is less than negative 6, okay, the number that's less than, you change whatever's inside here equal to negative, because you want to make it positive, right? Because if the number is less than 6, say 0, 1, 2, 3, 4, 5, the number in here is negative, right? But since we want it to be positive because of the absolute value, we put a negative out front. So that means any number before 6 I pick, right, will be negative in here, but I'm turning it positive with a negative out there. But we don't need to put a negative sign out front. We can just use it regular if x is greater than or equal to 6, right? Because if x is 6, the answer is 0. If x is anything bigger than 6, like 7, 8, 9, 10, 11, all the way to infinity, that minus 6 is going to be a positive number. Okay? So this way, this is negative because if I plugged any number in here less than 6 into this equation, my answer would be negative. But the absolute value things makes it positive, so I put the negative out front. Negative times a negative is a positive. All right, I know it's a little difficult to pick up on a video, but hopefully you guys kind of get it. It's easier in class when I do thousands of examples. You're going to split this into two different intervals. All right, so the first integral is going to be anything less than 6. So zeros are small, so it's from 0 to 6 of 3, right, times negative x minus 6. Plus, what do you think the next one is? 3 times the integral from, what numbers? 6 to 7, x minus 6. Got it? Any questions? Pull that negative out. So you got negative 3, integral of x minus 6, x squared over 2, minus 6x, from 0 to 6. All right, integral from this to this, right? The 3's already out, right? X squared minus 6x, from 6 to 7. Now you notice the only difference here is this has a negative out front, and this doesn't. The integrals right here are the same. I mean the integration. So now what you do is you're going to, you follow me? Integrate this, integrate this. The only difference is this negative sign out front. But this is from 0 to 6, this is 6 to 7. And 0 to 6 plus 6 to 7 would be 0 to 7. Now, type 6 in here. 6 squared is 36 divided by 2 is 18. 18 minus, 6 times 6, 18 minus 36 is negative 18. Negative 18 times 3 is 54. Okay? Got it? 54, if I plug 0 in here, the answer is 0. 54 minus 0 is 0, 54. So this whole answer right here is 54. The way I got 1/2 here, all right, there wasn't enough space, I got to explain it all. 7 squared is 49 divided by 2 minus 6 times 7 is 42. So the answer here would be, what did I say? No, yeah. 42 divided by 2 is 21, minus 42 is negative 21 times 3, negative 63, and then the 6 gives you 1/2. Answer is 54.5. Got it? Good? Hopefully. Alright, let's move on. I think that's right. Gave up in my head doing the math. If it's not, I'm sorry. All right, ready? 27. I want you guys to try this real quick. I'll walk you through it in case you're having trouble. Get that pause button ready. So first thing I want you guys to do is solve for x to see where we're splitting this from 0 to 2. All right, so you should have did 2x minus 1 equals 0. Add 1, divide by 2, and x equals 1/2. So we're splitting it at the 1/2. No, you don't have to split it at a whole number. Next thing right here, create piecewise equations. So, where are we going from? 0 to 1/2. So it's negative 2x minus 1. So that's when you are less than 1/2. And you are 2x plus 1 when you are, no, sorry, positive 2x minus 1. This all stays the same. The only thing that changes is the negative out front. When you are greater than equal to 1/2. If you want to put the equal to there instead, that's fine. Doesn't really matter. All right. You can actually leave equals on both of them. All right. Ready? Are we good? We good? Set it up. The integral from 0 to 1/2 of negative 2x minus 1 plus the integral of from 1/2 to 2 of 2x minus 1. And both are dx because you're doing it in terms of x. You can pull out the negative here if you want and integrate. Everything else will be the same. This would be 2x squared over 2. Oh, sorry, x squared over 2. 2 divided by 2 is 1. This would be minus x from 0 to 1/2. This, there's no negative out front, and you have the same integration from 1/2 to 2. You're going to plug in your 1/2 into both these problems. So you have 1/2 squared minus 1/2, and the negatives out front, so that becomes 1/4 minus 1/2, minus 0 over 0. And then this becomes plus, you plug in these numbers. 2 squared, which is 4 minus 2, minus 1/2 squared, which is 1/4 minus 1/2. This becomes right here, like I said before. Negative 1/4. 2 negatives is a positive. This becomes 2 minus negative 1/4, so this becomes 2 1/4. 1/4 plus 1/4 is 2 1/2, or 5/2. See, that's not too terrible, is it? Can you guys see the light blue? Hopefully. Oh, good, it came out right. Now, just so you guys know, what you're doing here is, with your piecewise, this is my actual graph. All right? From 0 to 1/2, so from 0 to 2, sorry. From 0 to 1/2 is this part of the graph. That's your 1/4. From 1/2 to 2 is this part of the shaded graph. That's the area is 2 1/4. So you just add these two areas together, and you get 2 1/2. So that's pretty much what you're doing. You're doing the downward part is the first part, and then when it goes back up is the second part. Got it? Because normally, if it wasn't a absolute value, this graph would continue down, and you'd have this top piece shaded, which is negative, but in this case, it's positive. Hopefully that explains a little bit better. So you could do another example. Oh, it's very similar. It's 2x minus 5 this time instead of 2x minus 1. But it's 0 to 5. So do this problem. Alright, let's look at our answers. 2x minus 5, you said it equal to 0. 2x equals 5 and x equals 5/2. So next step, we set up our piecewise equation. If x is going to be negative, if x is less than 5/2 or 2.5, and it's going to be positive if x is greater than 5/2. We still okay? Set up our integration from 0 to 5/2. You have the negative. All right, from 5/2 to 5, you have the positive. So just pull that negative out front, integrate this, and that it has the same integral. All right, so 2x squared over 2, which is x squared minus 5x. Oh, what did I do here? Why did I write the same exact thing twice? Oh, this and this is the same thing. Oh, I distributed the negative in there. All right, you can do that too. I don't know why I did that. That's kind of stupid. But anyway, you can distribute the negative in here if you want. Make this a negative 2x, positive 5. That gives you negative x squared plus 5x plus a positive x squared plus 5x. All right? And then your upper limit, lower limit, upper limit. I usually like to just leave the negative out front. I guess I just was showing the class how you could do it a second way. All right, plug 5 halves in here. 5 halves squared plus 5 times 5 halves minus 0 squared minus 5 times 0. 5 in here, 5 squared minus 5 times 5. Ooh, that's 0. 5 halves squared minus 5 times 5 halves. Reduce 25 over 4 minus 25 over 2. 0, 0. 25 minus 25. 25 over 4 minus 25 over 2. This becomes 25 over 4 minus 50 over 4, so negative 25 over 4 minus 0. 0, this is negative 25 over 4, which is a positive 25 over 4. 25 over 4 plus, remember these are pluses, not minuses, is 25 over 2, or 12.5. All right, this is all just math, numbers, calculator. All right, getting up to here, calculus, this, number sense. Got it? Let's see, should we do one more? What do you think? I heard someone say yes, so we'll do one more. See that? Magic. Let's go. X minus 3 equals 0. X equals 3. So, when x is less than 3, it's negative. When x is, I should say greater than. First mistake. All right. So when x is greater than 3, it stays the same. Oh no, sorry, I'm wrong. This is the same thing. I distribute the negative in there right away. Negative x plus 3. When x is greater than 3, x minus 3, and x is greater than 3. Yes, I didn't mess up. All right, so anyway, from 1 to 3, that's your integral, right? 3 minus that. 3 minus the normal. Notice the only difference is these are changed. Okay, where this was, change both signs. Positive to negative, negative to positive, because it's less than. When it's greater than, this stays exactly the same. I guess that's why I changed it. Where'd I go? Distribute the negative from here and here, positive and negative. So this becomes 3 minus 3, which is 0. Negative negative x is a positive x. 3 minus negative 3 is positive 6, and this becomes a negative x. So now look, the answers actually look, the things you're integrating are quite different. Integrate this, x squared over 2, negative x squared over 2 plus 6x. From 1 to 3, negative x squared over 2 plus 6x. Or negative 1/2 x squared plus 6x. Whichever one you want. Plug some stuff in here. 3 squared over 2, 9 over 2 minus 1/2. Plus, this one's a little more difficult because it's got more stuff going on here. 16 over 2 plus 24. 9, I'm going to do it here. 9 squared, 9 over 2 minus 1/2. 8 plus 24. 9 over 2, 18. 9 halves times 1/2 is 8 halves, or 4. Negative 16 plus 24. Negative 8 plus 24 is 16. Negative 9 halves plus 32 over 2 is minus 27 over 2. 5 halves plus 4. 4 plus 2.5 is 6.5. 6.5. 13 over 2. Whatever you want to write it as. There you go. You guys are masters of absolute values. You think that's good enough? What do you think? Yeah? All right. We're done with absolute value. All right. Let me back up here a little bit. Continue on. Find the area of the region bounded by the graph. Y equals 2x squared minus 3x plus 2. The x-axis and the vertical lines. X equals 0. And x equals 2. So first thing you want to do is you want to create an integral equation. So, how do you think you create an equation? Like you just had. Not the absolute value one, but the one at the beginning of the video. Obviously, we're integrating this. What's my lower limit sum? Look at the graph, you don't see it. 0. What's my upper limit sum? 2. So I have the integral from 0 to 2, and the equation is this, and what are we integrating in terms of? X. So dx. See, that's easy. So you can create it, integrate that now. You guys can integrate that. Good. 2x cubed over 3 minus 3x squared over 2 plus 2x dx. And now you're going to reduce this. This is 2/3, this is 3/2, right? From 0 to 2. Now you're going to solve it, just as we did in the beginning of the period. Beginning of the video. See, back in school mode already. B, A. So you type 2 in here. 2 cubed is 8. 4. 0, 0, 0. So you got 2/3, 8. 3/2 times 4. So this is 16 over 3 minus 12 over 2 plus 4. Oh, there we go. 10/3 minus 0 is 10/3. 3 1/3. 3.33333 and a bunch more 3's. That is the area of this pale blue section, bounded by the x-axis, bounded by x equals 0, bounded by x equals 2. Good? That's it. 34, 35, 31, 32, 33, 34. Bang out all 4, and then we'll go over all 4. Almost done. Make sure my video's still going. Good. Ooh, almost an hour. That's a long one today. All right, there we go. Create your integration. You have your little symbol, integral symbol, antiderivative symbol, lower limit, upper limit, 0 to 2, equation dx. So, step 1 right, step 2 integrate. So you got from 0 to 2, 5x cubed over 3 plus 2x. All right. Next step, plug some stuff in. All right, so I'm going to just make this a 5/3. 2 cubed plus 2 squared minus 5/3, 0 cubed plus 2 times 0. 5/3 times 8 plus 4. 40 over 3 plus 4. 40 over 3 plus 12 over 3 is 52 over 3. This obviously is zeros the whole time. You don't even have to write it out. It's just nice to do. So 52 over 3, or what do we got here? We got a number 17 1/3, 17.3333. 32. And the y equals 0 just means you're doing it with the x-axis. That's what the y equals 0 is. If this wasn't y equals 0, it would change immensely. That's not even in this lesson. Might not even be in this chapter. All right, so x to the 4th over 4, x squared over 2. 2 to the 4th, 2 squared, blah, blah, blah. 0, so they don't matter. 2 times 2 times 2 times 2 is 16 over 4. 2 times 2 is 4 over 2. 4 plus 2. 6 minus 0 is 6. All right. Ready to do 2 more? Well, no, you're not ready because you already did these 2, right? Hopefully you rewrote this up. 0 to 8. 1 plus x to the 1/3. The reason you rewrite it is it's easier to integrate. X, 1/3 plus 1 is 4/3. X plus reciprocal of 4/3 is 3/4 x to the 4/3 from 0 to 8. Type an 8 in there. Type a 0 in there. Obviously a 0 again. 8 plus 3/4 of 16. What's that? 50, nope, 30, 48 over 4. 8 plus 12 minus 0. 20 minus 0 is 20. All right. Distribute this in here. Now, I don't got letter numbers here. So we have to find the x-intercept since the boundary is just the x-axis. So what that means is your boundary is just the x-axis, all right? So there is no left and right. So what that means is it's just pretty much anything that's above the x-axis where it hits each part, all right? Because you're not given that. So the way to find the x-axis first off is you're going to set this equal to 0, all right? That tells you if hopefully it hits at 2 points. And once again, this is like advanced upper limit AP style stuff. Take the radical x and distribute it in both of them. Oh wait, no, we're not. We want this to equal 0, so we're just going to set these both equal to 0. I just lied to you. All right, so add x to both sides. X equals 3. Then you set radical x equal to 0 and x equals 0. So these are my two intercepts. Sorry, I was doing the next part. So that means my upper and lower limit sum are 0 to this. All right, so what that means is at 0, my graph does something. I don't know. I'm just going to say it makes a loop, and then it connects the 3 over here. So from here to here, the graph's all above the curve. You can find the area of that. Got it? And this is what I was doing before. I was jumping the gun here. This is x to the 1/2, so 3x to the 1/2 minus 1 plus 1/2 is x to the 3/2. So when you set things equal to 0, you just set each peach equal to 0, because 0 times whatever this is equals 0. Whatever this is times 0 also equals 0. My bad. Integrate. 3/2, negative 5/2. Whew. See, talking this long exhausts everyone. Reciprocal, 2/3, 2/5. Type in 3. Type in 0. 0, you get a 0 out. 3 to the 3rd square root, 3 to the 5th square root. It's going to be 2 decimals. Subtract these 2 decimals, you get 4.2. Once again, 0, 0, 0. Answer is 4.2. All right. Not terrible, not easy, above what you're going to be doing in this class, but always good to go a little bit above and beyond. Give you guys a little extra work. All right, ready for the next one? How long have we been doing this? Oh, about an hour. All right, so mean value theorem of integration, right? If f is continuous on the closed interval AB, then there exists a number c in the closed interval AB such that the following is true. The integral from a to b of f of x dx equals f of c. What does that mean? Times b minus a. Now this is just a formula that we'll be using. This kind of looks formula. Forgot to say words. We did the mean value of differentiation. So we have done this before. Now it's just integrals. Okay, we did the derivatives. Lower limit sum, upper limit sum. All right? Follow me so far? C is a point that's between those two sums. C is always between A and B. That's what that means. F of C, okay, is pretty much how it's the formula. F of C is the y value at C. Okay, so I could actually put that there if I wanted to. So C is the x value, F of C is the y value. The goal is to find the value of C, what the average number is, okay? Now, that's the mean value. Mean, average, remember you did this in statistics. All right, so step 1. Oh, why did I put steps there? That's weird. Solve, this should say integrate. I don't know why that says steps again. Ooh, solve using f of a minus f of b. Find f of c, b minus a, all right? Set number 2 equal to number 3. So you're going to set these two things equal to each other. And you're going to solve for c. It's so weird that I wrote the word steps there. It should say f of c. I got to fix that. So there's, let me explain this to you real quickly. You have an inscribed rectangle. We did this before, right? Oops, inscribed rectangle. This is like 5.2. That's a little bit less than the actual area, right? That's when we used our integral from a to b, and that equaled little f of m. You remember that? Area slightly less than your minimum. Mean value theorem is actually going to be pretty much equal to the actual area. That's going to be a true integration. All right? Then we had our circumscribed, which was a little bit greater than. That was what? Integral from a to b. We didn't use regular, we used what? F of big N. All right, that was your maximum. So instead of the maximum minimum, we're going to find right in the middle. That makes sense, hopefully? And this is our f of c. All right, so let's do some problems here for 35 to 39. Find values guaranteed by the mean value theorem, MVT, for the integrals of the function over the following integrals. So First step is to integrate. So integrate. When you integrate, see, I knew it shouldn't have said steps. What you're going to do is take the integral from lower limit term 0, upper, is 3. All right, of x squared dx. All right, so when you integrate that, you get x to the 4th over 4 from 0 to 3. Step 2, find f of b minus f of a. So you're pretty much finding the indefinite integral, or the definite integral. F of a minus f of b. I wrote that backwards. We should say f of b minus f of a. It's 2 mistakes in a row. 3 to the 4th minus 4 over 4, 0 to the 4th. So you got 81 over 4 minus 0 over 12. 81 over 4. All right, follow me still? All right, step 3, find f of c, b minus a. So f of c is what? How do we find f of c? Substitute the s with the c. So it's f of c equals c cubed, b minus a is 3 minus 0. Another mistake. C cubed, 3 minus 0. All right, equals c cubed times 3, or 3c cubed. That's cubed. Why is this all saying squared? Said 2 and 3 equal. Oh no. 81 over 4 equals 3c cubed. That should say 3. Divide by 3. C cubed equals 27 over 4. And the answer is, it's not 1.89. I gotta go get it in real time. Go change my answer on the fly. The answer is the cubed root, not the squared root, of 27 divided by 4. I'll tell the answer right now. 27 divided by 4. And the 3 cubed. Oh, that's actually the right answer. This should all say 3's, but that is the correct answer. I just wrote the wrong exponent. And I thought I checked everything here too. All right. I'll fix that on the master sheet. All right, so do problem number 36. All right, so 36, 9x to negative 3 dx. So this becomes 9, negative 3 plus 1 is negative 2 over negative 2. Negative 9 halves. All right, or negative 9 over 2x squared, 3 to 1. All right, since this is a negative 2, I throw it back in the denominator. Put 3 in here, 3 squared, 1 squared becomes negative 1 half plus 9 halves. All right, because negative 9 over 18 is negative 9 halves. So your answer is 4. This one, f of c, 3 minus 1 equals 4. Right, what's f of c? 9 over c cubed times 2. 3 minus 1 is 2, equals 4. Follow me? 2 times 9 is 18. Multiply both sides by c cubed. Divide both sides by 4. C cubed equals 4.5. The cubed root of 4.5 is, drum roll, about 1.65. Right? Yeah. Yeah, all right, good. There's 738. What do we got? Oh, man, it's a long lesson. X to the 1 half. Integral of x to the 1 half is x to the 3 halves over 3 halves from 4 to 9. 2/3. X to the 3 halves from 4 to 9. F of b. Type in 9. F of a. 2/3 27 minus 2/3 times 8. Answer is, drum roll please, 38 over 3. All right. F of c b minus a. So to find f of c, you type in your square root of c times 5. 5x to the 1/2 if you want. You don't have to put it like that. So I'm going to divide both sides by 5 here, making that 38 over 15. In order to get rid of that, you square both sides. So 38 over 15 squared is 6.42. We all good? All right, 37. You're going to rewrite that first. X minus 2x to the 1/2. You can integrate it. X squared. X to the 3/2 over 3/2. Integral of that is 2/3. 2/3 times 2. 2 times 2 is 4 over 3. Type your 2 in. Type your 0 in. All right. Simplify that. You get an answer. Negative 1.77. All right. Any questions? Email me. All right. F of c, 2 minus 0 equals negative 1.77. F of c just equals c minus 2c. 2 square root of c. This is a little tricky. Take this 2. You can distribute it, but why not just divide both sides by 2? Negative 1.77 divided by 2 is negative 885. Negative 885 thousandths. That's why I don't like to say thousand this, because my TH is bad. Now what do we do? How do you think we solve for this? Why don't we subtract c from both sides? Now what can we do to both sides? Any clue? What did I do here? I squared both sides. Now watch why I did that. Negative 2 radical c times negative 2 radical c is positive 4. Radical c times radical c is c. We gotta get rid of the radical. When I square this, this pretty much becomes a FOIL, multiplying this by itself. So this squared is 0.78 minus c times this minus c times this. So since they're both negatives, they become positive. 1.77c. Negative c squared is positive c squared. I can make a quadratic. I subtract both sides by 4. C squared minus 2.23c plus 0.78. Now how do I solve for c here? I factor, right? Use the quadratic equation. Now if you use the quadratic equation, I should have gave this as on a slide. You get about 2.04 or 0.19. All right. You can have more than one value for c. It's a little weird though, right? Now, here's the deal. Quadratic equation, negative b plus or minus square root of, what's b squared minus 4ac, the whole thing over 2a. All right, that's how I get that. Okay? Yeah, all right. Anyway, let's keep on moving here. Definition of the average value of a function on an interval. So f is integral on the closed interval a, b, then the average value of f is on the interval is 1 over b over a, integral of a to b, f of x dx. So, another formula here. Bunch of formulas. So, the way this works is, average value, if you have, say, like a Kirby thing, right? Average value is the average. You take the stuff above, take the stuff below, and you want to average them out. There's always a line between where that would make it equal to 0. So, step 1. So, you're going from a to b, between 2 points. You're going to plug a, b, and f of x into this equation. All right, step 2. You simplify it, you integrate it. Step 3. Find f of b and f of a, and subtract. That seems pretty easy, doesn't it? So let's see how this works. So, find the average stuff right here. First thing, plug a, b, and f into this equation. So I set up this equation here with a bunch of blank stuff. So let's look first. Let's look at b. b is what? 4. So 1 over 4 minus a is 1. From 4 to 1, or from 1 to 4. And then this becomes your equation. See? 4, 4, 1, 1, equation. Awesome. All right. Step 2. Simplify, integrate. I already simplified it for you. 1/3 from 1 to 4, right? of this equation, right, is 1. 4 minus 1 is 3. Integrate. This is a constant, stays up front. X cubed over 3, x squared over squared. 3 divided by 3 is 1, 2 divided by 2 is 1. So this just becomes 1/3 times x cubed minus x squared from 1 to 4. All right, find f of b, f of a. So plug the 4 in, put the 1 in. 4 minus 4 minus 1, 1, right? 4 cubed is 64, 4 squared is 16, 1 cubed, 1 cubed. 1/3 of 48 minus 0. Still following? 1/3 of 48. 16. Alright, why don't we try a couple of these on your own? So for 40 to 44, find the average value theorem of the theorem over the interval with all the values of x in the interval which the function equals the average value. So, step 1. 1 minus b minus a over from a to b of the function equals 3 minus 3 is 1/6 from negative 3 to 3, 9 minus x squared dx. You're going to integrate right here. You got 9x over x cubed over 3 times 1/6. All right, so when we do this, 1/6, 9 times 3 minus 3 cubed over 3 minus f of a, 9 times negative 3, right? Minus negative 3 cubed over 3. And now you're with your algebra again. 1/3, 27 minus 9, minus negative 27. Negative 27 divided by 3 is negative 9. All right. 18 minus the negative is negative 27 plus 9 is negative 18. 18 plus 18 is 36. 1/6, don't forget you have your 1/6 out front here still. 36 is 6. All right. That was pretty easy, wasn't it? Problem 41. You okay with this? All right, go. First thing you're going to do is you're going to simplify. Distribute the 4. When you distribute the 4, 4x squared plus 4 over x squared. Now you're going to divide both of these by x squared. So you get 4 x squared divided by x squared is 1. 4 divided by x squared is 4x to the negative 2. So all I did was I rewrote the equation. Now I can plug it into my master equation. 1 over b minus a. 1 over 3 minus 1 from 1 to 3 of the equation. 3 minus 1 is 2, so it's 1/2 from 1 to 3 of this equation. I integrate 4x. 4x to the negative 1 divided by negative 1. Negative minus negative and negative is a positive, so it's just 4x plus 4 over x, or 4x plus 4x to the negative 1. Plug the 3 in, plug the 1 in. So, if you want, you can take this 1/2. 1/2 of 4 is 2. 1/2 of 4 is 2. All right, now I'm done with the 1/2. Now I'm going to expand it. Forgot the last simplify step. So, let's go. Plug the 3 in. This is your f of b. This is your f of a. 6 minus 2/3 minus 2 minus 2. Oh, look at that. What is 2 minus 2? 0. 5 1/3 minus 0 is 5 1/3. Or 16 over 3, or whatever you want to make. That equals 16 over 3. All right. Ready? Let's do problems 42, 43. And then we're going to move on to something different. 42. Formula. 1 over b minus a. 0 from a to b. X cubed. What's 1 divided by 1? 1. So you got 1 from 0 to 1 of x cubed. All right, so I'm going to integrate x cubed. You get x to the 4th over 4 from 0 to 1. All right. What you're going to do is you're going to type in 1 and you're going to type in 0. So you got 1/4 minus 0 over 4. 1/4 minus 0 is 1, 4. All right, problem 43. Type in your stuff. 1 over b minus a over from negative 1 to 2 of this equation. So 2 minus negative 1 is 1/3. From negative 1 to 2 of 4x cubed minus 3x squared. Now, integrate this right here. 1/3, 4x to the 4th over 4 minus 3x cubed over 3 from 1, negative 1 to 2. X to the 4th, 4 divided by 4 is 1. Negative 3 divided by 3 is also 1. So 1/3 x to the 4th minus x cubed from negative 1 to 2. All right, now, what you do next is you're going to plug in your 2. You're going to plug in your negative 1. 1/3 times whatever your answer to all this is going to be. 2 to the 4th minus 2 cubed. All right, minus negative 1 to the 4th minus negative 1/3. 16 minus 8 is 8. 1 minus negative 1 is 2. 1/3 of 6 is all that to get 2 as an answer. All right. Hopefully you're still doing well, and that is the average numbers. All right, next part, second fundamental theorem of calculus. All right, this is a quick little theorem, and we're almost done for the day. Now, definite integral as a number. This is what you have been doing. This is what your definite integral looks like. Your a and your b are two constants right here, right? And then your f of x is your function of x. So this is your start point, your lower limit sum, your upper limit sum. Those are both actual numbers. And this is what you're finding the function of. The definition of an integral is a function of x, though, not as a number. You start at a, which is a constant, and this x is a constant, but it's also a variable. And you're trying to find f as a function of t. So you're going to plug the variable into your function. All right? Now, the definite integral as a function, let me show you how this works. And it actually, keep saying the word actual. You're going to keep on substituting different constants in for that x. So, as your first step, what you're going to do is you're just going to integrate that. So everyone integrate. All right, everyone should know the integral of cosine is negative sine. So step 1, actually the cosine, integral of cosine is sine. So it's sine t, you're doing in dt, from 0 to x. Now, when I plug this stuff in, I'm going to take an actual derivative. So it's sine x minus sine 0. Sine x just stays sine x because we don't know what it is, and sine 0 equals 0. So the integral of sine t from 0 to x is just sine x. Now, why would we do that? Well, in real life, when you're doing experiments, what you do is you plug in different variables in for the same thing. Why do the same equation over and over? So you're going to want to know when x is 0, this, and all those things. So you're just going to take all these x's, and you're going to plug them into the final answer, and it's going to really quickly spit out your answers. So when we plug this stuff in, sine 0 equals, we said before, 0. So what that means is, when x is 0, okay, going from 0 to 0, there's no area under the curve. Now when it's pi over 6, notice there's some area right here. So sine pi over 6 equals 1/2. So that means this light pink bright part right here, the area is 1/2. If I typed in sine pi over 4, what do you think it's going to be? Probably a little bit more, right? It actually would be. It'd be radical 2 over 2. I think that's like 0.76-ish. Notice a little more. If I typed in pi over 3, notice, look at, you've gone a little further down, a little bit more area. The answer is radical 3 over 2. If I typed in pi over 2, you got this whole little piece here filled in. Your answer is 1. All right, so as you type in different numbers, constants in for your variables, they change. All right. That's the quick little second theorem. It's not too bad. What you're going to do is f is continuous on an open interval I containing a, then for every x on the interval. So this is how it pretty much works is you set up your integration. So your answer here is going to be f of x, all right, f of x. So the derivative of from x to a equals 1. That's weird. Why would it do that? Because everything cancels out. All right, so when you take a derivative and you take an integral and you put them together, you end up with a 1. It's almost like when you divide 2 by 2, when you multiply 3 by 1/3. Derivatives and integrals just cancel each other out. All right, so using the second fundamental theorem of calculus, if I was going to find the derivative of an integral, it would just be whatever the function is. Your answer would be x squared plus 1. You would just take the x, you plug it in for t squared, and your answer would be 1. I mean, it would just be whatever's under here. That's it. All right, last concept is the net change theorem. The definite integral of the rate of change of a quantity, f prime x, gives the total change or the net change in that the quantity of the interval from a to b. So what that means is the net change of f from a to b, when you take the integral of a derivative, equals whatever f of b is subtracting f of a. So net change right here. Type in, integrate x squared over 2 from 10 to 8. 12 divided by 2 is 6, x squared from 10 to 8. Type in your b, type in your a. 6x 10 squared minus 6 times 8 squared. Net change is 216, just like we did before. All right, and let's finish this up, showing you how this is used with a problem. Oh, we only have one problem left. So a chemical flows into a storage tank at the rate of 180 plus 3t liters per minute. Now this is where you would use all this stuff, where t is between 0 and 60. Find the amount of chemical that flows into the tank during the first 20 minutes. So this is saying your t is between pretty much the first hour. So first thing you need to know is, what is C of t? What's the actual word? C of t is the chemicals in the tank. All right, so that's the chemicals in the tank for whatever your time is. So what do you think the derivative of that would be? What would be the derivative of the chemicals in the tank? In words. Hopefully you said the rate at which the chemicals flow into the tank. All right, so derivatives are rates. This is your actual amount. Your derivative is your rate. Now, we already said the flow rate is that right there, right? So can we find the chemicals in the tank? Of course we can. In the first 20 minutes, that would be from what? 0 to 20. First 20 minutes. And your equation would be C prime t, right? So we're going from 0 to 20. That's our first 20 minutes. From 0 to 20, 180 plus 3t dt, right? Integrate this. 180 t plus 3 over 2 t squared from 0 to 20. Type in your b, type in your a. All right. 3,600 plus 600 minus 0 is 4,200. So what this says is, at 20 minutes, from 0 to 20 minutes, there would be 4,200 liters that were pumped into that tank. All right, and you can find this from any time to any time. And that's how net change theorem works. All right. And finally, your little physics. Displacement is just using v of t, velocity. So it would be your area minus your area plus your area. So with displacement, you would add up all the areas together. If you're finding something like total distance, what you would do is you would take the absolute value. So displacement's different than total distance. So I add all the areas together. So I'd count this, I count all this, and then I count all that. All right, so that's why displacement is the actual amount of area you have. Total distance is you're adding them all together. All right, and then the A's are obviously the shaded area. This green one's obviously negative, but like I said, when you do total distance, you would just absolute value that, so you would add it. All right, this is much later on. All right, so last question of the day. Long day, but it's the last question. Particles moving along a line, so the velocity is t cubed minus 10t squared plus 29t minus 20 feet per second at time t. What is the displacement, okay, on the time of the interval from 1t to 5? So, first thing you do, you have your integral from 1 to 5 of t cubed minus 10t of the equation, right? When you do that equation, you integrate it. T to the 4th over 4, t to the 3rd over 3, give your 10, 29, t squared over 2 minus 20t. What do you do after you integrate it? Plug in your b, plug in your a. 1/4, you plug all your 5's in. 1/4, you plug all your 1's in. Now you just solve mathematically. You don't need me to explain this all. You should know it. This all becomes 25 over 12. This all becomes negative 103 over 12. All right? If you used regular decimals, that's fine. Your answer is 32 over 3, 10 2/3, or you could say 10.67. That's displacement. Now, distance, which is different, is we wouldn't do all the subtractions, okay? Because look at this is positive here. Once you go from 4 to 5, it's in the negative. So what you would have to do changing here is you would have to use your absolute value, okay? Now I'm just going to use this right here. You would really want to find out where the intercept is. You do that using some advanced math, but in this case you can just use the graph because I don't really have time to get into that. So from 1 to 4, where it's positive, you have your equation. And then from 4 to 5, all right, you're just going to add whatever the value is there. So I find the value here from 1 to 4. I find the value here from 4 to 5. I'm going to add in 4 for my t's, 1 for my t's, 5 for my t's, 4 for my t's. You get 8/3 minus negative 1 over 3 over 2 plus 25 over 12 minus 8/3. Now, instead of just putting a negative out front, I'm just going to take the absolute values of both of these to make them positive. 45 over 4 plus 7 over 12 is now both my areas are indeed positive, and my answer is 71 over 6. And that's it. So distance over time, now notice these are a little bit different. 71 over 6 is 11.83. So just by adding this instead of subtracting this, I got a little bit extra. That's the total distance traveled by the particle. This is the total displacement. Right? It's a little bit different. Anyway, that concludes 5.4. Hopefully you guys did very well in this. Hopefully you guys kind of get it. No, it went a little bit quick at times, but like I said, a long lesson. You guys are probably exhausted by now if you shot through it, but hopefully you got something, right? So, until next time, have a good day.